Okay, the test 4 study guide for Algebra 2, first problem. It says find 4 consecutive integers. Okay, as soon as I see those words, I want to establish algebraic unknowns to represent consecutive integers. Consecutive integers have a +1 pattern. That's how I'm going to create them. So some integer, add 1, that's the next bigger integer, add 1 more, and add 1 more to create a list of 4 consecutive integers. Such that is where the equation starts, and then we start translating the words. Twice the sum means 2 parentheses. You can't multiply a sum without parentheses, so twice the multiplication of 2 times the sum immediately gets me to parentheses. And when I see the words the sum of, I'm looking to add stuff. This says the sum of the first, second, and fourth. So we're adding 3 things here, first, second, and fourth. So n plus 1 plus n plus 3. N parentheses. Okay. We're doing twice the sum. This is the whole sum, so the entire sum gets encased in parentheses. I see the word is, that's equals. I see 20 greater than. I don't care about 20 greater than until the end. Then it says twice the opposite of the third. All right, so let's focus first of all on the opposite of the third. This is the third. The opposite of the third is minus n minus 2. Be careful, if you're going to opposite multiple pieces, you have to opposite sign every piece of that thing. We want to do twice that thing. Now, minus n minus 2 is 2 things, so to do 2 times 2 things, once again, parentheses are necessary. So be cautious of that. When you need to multiply any one of these individual pieces times a number, they're binomials, you have to put parentheses. If I wanted to multiply 2 times n, that's no parentheses necessary, because n is just a single object. All 3 of these are represented by multiple objects, so multiplication by any one of those has to be done in parentheses. So create a good equation, and then, almost forgot my 20 greater than. Okay, is 20 greater than. So the word is happens, that's where equals is. 20 greater than happens after the word is, so we're going to put a plus 20 all the way on the right-hand side. That's usually the side we fix, the right-hand side. Just put your plus or minus 20 based on the word greater or less. Greater, add, less, subtract. Okay, once we create our good equation, now we go ahead and start solving that equation. For me, I like to simplify inside parentheses before I distribute. So I'm going to keep 2 right here, parentheses. N plus n plus n is 3n. 1 plus 3 is 4. So 3n plus 4 is a simpler version of n plus 1 plus n plus 3. Over here I can't make this any simpler, so I go ahead and distribute that. 2 times minus n is minus 2n. 2 times minus 2 is minus 4. And plus 20 is not in parentheses, so it just comes along. At this point I distribute here. 2 times 3n is 6n. 2 times 4 is 8. Over here, like terms, I get negative 2n plus 16. So what's left to do to solve is I've got to get n on the left and number on the right, or vice versa. As long as they're on opposite sides, it doesn't matter which side you decide to move things to. 2n becomes positive, 8 becomes negative. Those are the 2 things I moved. The 6n and 16 didn't move, they stayed what they were. 6 plus 2 makes 8n. 16 minus 8 makes 8. Addition because the signs are the same, subtraction because the signs are different. If 8n equals 8, that means that n would have to equal 1, because we divide both sides by 8. Once we know n equals 1, it says find 4 consecutive integers. We found 1, we add 1, then 2, then 3. So 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. Each case, n is 1, n is 1, n is 1, n is 1. 1, 2, 3, 4. Make sure you give me all 4. What I do on tests on a problem like this, if I'm asking for 4 and you give me 1, you lose 3/4 credit because you only gave me 1 of the 4 answers. So be careful. One thing to be cautious of here, if you happen to get n equals a negative number, let's just go a new page up here. Suppose we have n plus 1, n plus 2. Let's just go 3 this time. Let's say we get n equals negative 6. Negative 6 plus 1, negative 6 plus 2. That's officially what we have because each n is a negative 6. Negative 6 plus 1 is negative 5. Negative 6 plus 2 is negative 4. Be careful to go the right direction. I saw some of you not going the right direction in that scenario, so be careful that you do that correctly and see where it's coming from, hopefully. Number 2, the little train had completed 40% of the journey. Okay, and again, what I've told you to be careful of here with percent problems and word problems is what happens after the word percent. Percent of makes it a part whole percent problem. So, completed, did not complete, and total. So completed, had completed 40% of the journey. So what he completed was 40%, that's a part. The other part is what he did not complete, which would be the rest. They always add up to 100 in a part whole situation, so the total is 100. Okay, so they only gave me the 40. I could figure out these two very clearly because, again, percent of tells me it's a part whole, making my total 100. I know the parts have to add up to 100, so 40 and 60, obviously. Okay, continuing on. We have actual amounts, all right? It says 2,400 miles still remained. So still remained represents what was not completed. What they completed is what's done. What they did not complete is what remained. So 2,400 miles, the actual number of miles still remaining is 2,400. And it says what was the total length of the journey. That's what they're asking us for. Read the problem carefully, make a good understanding of what the problem's talking about. See that it's a part whole problem to begin with. Create a proper structure for the part whole. Make sure everything goes where it belongs. The number they gave me is actually not helpful at this point. It's very helpful to find this number, but it's not necessary at this point. So 60 over 100 is equal to 2,400 over x. That's 60x equals 24 followed by 4 zeros. 2 for that, 2 for that. Divide both sides by 60. And that cancels that. 24,000 divided by 6 is 4,000 miles. Expect it to be similarly set up on the test. I'll tell you what percent has been covered. I'll tell you how much remains and ask what the total length of the journey is. So the chart should be similar. It's just a matter of reading it properly and setting it up properly. Number 3, AB is a segment drawn along one side of a triangle. If x equals 150 and y equals 80, find z. Let me make this a little bit bigger. All right. My directions are very clear to find z, which is right here. Z is inside the triangle, and the three angles of a triangle out at 180. The problem is, they did not give me these two angles down here. What they did give me, that x equals 150 degrees. They also gave me that y equals 80 degrees. That's what they did give me. So looking at what they gave me, based on what I need to know to find out what they're asking me to find z, I need to know how big this angle is and how big that angle is. Both those angles are complete a straight line for the two angles they did give me. So if this is 150, this angle has to be 30 degrees because 30 and 150 make 180. If this is 80, then this angle has to be 100 because 180 makes 180. In both cases, we have a straight line created by two angles. The two angles have to add up to 180. So very easily I can determine how big these two angles are. And once I know those two angles make 130 degrees, z plus 130 degrees, this angle plus these two angles, has to be 180 degrees. Therefore, z would be 50 degrees. On the test, I'm going to give you the same picture. I'm going to give you x and y being different numbers, but the x and the y allow you to find these two angles. 180 minus these two angles gets you the angle you're looking for. I won't change the problem up at all except for the numbers that x and y equal. So be ready for that one. Be able to do it. Number 4. It says find x and y. We're going to find y first. For y is an inscribed angle for an intercepted arc. The relationship is that the angle here is half as big as the arc there. So y is going to be 1/2 of 70. So y is going to equal 35 degrees. I don't need to know any other information to figure out y. I've got an inscribed angle. I've got an intercepted arc. That's twice as big as this, so divide that by 2 to get y. On the test, you're going to have a y sitting right there. You're going to have an angle right there that you have to divide by 2. Okay, don't mess up on y. far as x is concerned, x is a part of an arc, and we got 70. This arc plus this arc plus this arc makes a whole circle, so they add up to 360 degrees. That's the rule. So 3x minus 20, the bottom arc, plus 2x plus 10, the top left arc, plus 70, arc over here. All three of those arcs together make the circle, so all three of those arcs add up to 360 degrees. That's the relationship that will happen on the test for x also. So 3x plus 2x is 5x. Negative 20 plus 10 plus 70 is equal to plus 60 equals 360. We simply solve the equation now. 5x is equal to 300. Move the 60 over, change the sign, opposite sign, subtract. 360 is bigger, so it's positive. Divide both sides by 5, we get x equals 60. Alright, so that's how you're going to find x and y on the test. The problem looked very much the same. I'm going to change these expressions. I'll probably change that number to something different so y doesn't equal 35. But these three arcs should add up to 360. If this came up 5x equals 27, the answer is 27/5. Fractions are allowed to be answers. I don't know if I made sure they all came out to nice pretty numbers or not. So just if this was 75 degrees, that would be 75 halves, 37 1/2 if you want. But again, do it correctly, get the answers you get. If they happen to be fractions, let them be fractions. Number 5, measures of angles A, B, and C are in the ratio of 4 to 2 to 3. What are the measures of the angles? So, we've already seen these problems before. A to B to C in the ratio of 4 to 2 to 3. So, that tells me that 4x equals A, 2x equals B, and 3x equals C. These ratio numbers, stick an x on them and put them in the same order that you got them there. Okay, so A is associated with 4, so A equals 4x. B is associated with 2, so B is equal to 2x. C is associated with 3, so C equals 3x. If A is equal to 4x, and B is equal to 2x, and C is equal to 3x, now instead of having 3 letters to represent 3 angles, we're using 1 letter, x, to represent 3 angles. And those 3 angles create this one straight line. So those 3 angles, 4x plus 2x plus 3x, have to equal 180. That means that 9x has to equal 180. Therefore, x has to equal 20. The directions don't say find x because I invented x. So be careful that the question says, what are the measures of the angles? The angles in the picture, if I unerase them, are A, B, and C. So their question is, what are A, B, and C? A equals 4x, 4 times 20 is 80. B equals 2x, 2 times 20 is 40. C equals 3x, 3 times 20 is 60. That's the answers they're looking for on that test. So I'm going to give you the letters A, B, and C. They're going to be in some ratio. Again, whatever ratio numbers show up, that number x for A, that number x for B, that number x for C. The 3 angles add up to 180 to find out x equals, and then you simply have to do whatever x is times each of the numbers to find what A, B, and C are. Number 6, adding algebraic fractions. You guys actually did pretty well on this in the homework, so hopefully it's carrying on. You didn't just learn it for the day, but you have it pretty well under control. The least common denominator is xy squared. X and y are the pieces in the denominators, and y to the second power is the biggest power of y, or should say the biggest power of y. 1 is the biggest power of x. This x on top doesn't factor into the least common denominator, it just happens to match this one, but it doesn't have to. Once you've established the least common denominator, then you simply create one big fraction bar, put the least common denominator in the bottom, and then modify each fraction appropriately to create that common denominator. So this fraction had a 1, now it's got an xy squared. So x is still x, the top. Xy squared is the new stuff. Plus the second fraction, 1 over x. Okay, it was 1, so 1 is what it was. X is what the denominator was, and y squared isn't there. Y squared is there now, so y squared is new. So again, what was it? What is it? What changed? That goes on top also. Then there's another plus sign here. The third fraction starts off as 2 over y squared, so 2 is still on top. Y squared was on the bottom, now it's xy squared. Y squared is the same, x is new, x gets multiplied by the top. So for each fraction, making this one big fraction bar, The top, what it was, times how you change the bottom. What it was times how you change the bottom. What it was times how you change the bottom. These signs stay the same. If that was a minus sign, that'd be a minus sign. Be careful that the signs stay the same. I've seen people miss these problems because they put wrong signs. All this have to do is to simplify as much as possible. The common denominator continues to be xy squared. X times xy squared makes x squared y squared. 1 times y squared makes y squared. 2 times x makes 2x. That is the final sum. Number 7, same family of problems, actually easier problem. So, these common denominators, the only denominator we have, y. So I'm going to make a big fraction bar with a y on the bottom. It says plus, I'm going to go ahead and put plus, make sure I don't forget about that. First fraction is 5 over 1, so it's still 5. 1 is what it was, y is what it is. What's new is the y. Second fraction, x over y. Y is what it was, y is what it is, so nothing changes, it just stays x. So 5 times y plus x all over y, which gives me a simplified answer of 5y plus x over y. Yes, those reduce, but not legally because that doesn't have a y. So be careful that you don't try and reduce stuff because you see how they have the same letter. Okay, same thing here. X, 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 no x, can't cancel x's. Y, 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 and no y, can't cancel y's. So probably you're not going to be canceling anything. So just get your answer, circle it, and move on to the next problem. Number 8. I did not include graph paper on the practice test. I'll try my best to remember to put graph paper on the test itself. If I forget, somebody be brave enough to say, Mr. Klein, can I go with graph paper? And that'll remind me and I'll make sure I pass it out to everybody. But anyway, I'll try my best to remember to put it on the other test, the graph paper. But we're going to find the distance between the points 3, 4. Here's the y-axis, here's the x-axis, x3, y4, 1, 2, 3, 1, 2, 3, 4. And the other point is 7, 7, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. For that point, the question asks us simply how far apart are these 2 points. So we're asked to find the distance. And the way we find distance between 2 points without using the distance formula is we determine how long that piece is and how long that piece is. So we create this right triangle and we find out how long pieces are by counting spaces. So from here to here, 1, 2, 3, 4 spaces. From here to here, 1, 2, 3 spaces. D squared is equal to 4 squared plus 3 squared. It's always hypotenuse squared equals leg squared plus leg squared. The legs will be the non-slanted sides. The hypotenuse will be the slanted side. Squaring 4 and 3 makes 16 and 9. D squared equals 25. And so therefore D is going to equal the positive or negative square root of 25. We only take the positive square root since D represents a distance. If the points happen to be horizontal to one another or vertical, it's just a matter of counting. I will say on the test I would expect a slanted line each time. So slanted line, find your horizontal and vertical distances by counting Pythagorean theorem to find the length of the slanted piece. Number 9, graph y equals, or y minus x minus 3 equals 0 on the given graph. Okay, kind of jumped the gun there. I want to get y equals to do it, so I want to get x and 3 both to go to the other side since y is all by itself by doing that. They're moving over there with a 0, so the 0 is just kind of holding on to a place. Once stuff moves over there, I can throw it away. So x becomes positive, 3 becomes positive. You can use slope-intercept method of graphing if you wish. You can use an xy chart if you wish. It doesn't matter. Let's just go xy chart on this one since it's really simple. 0, 1, 2, 3. Y equals whatever x is plus 3. Here's whatever x is. 0 plus 3 is 3, 1 plus 3 is 4, 2 plus 3 is 5, 3 plus 3 is 6. Y equals x plus 3. Take these x's, add 3's, and you get the answer. If I plot 0, 3, that's 0 on the x-axis, 3 up. 1, 4, 2, 5, 3, 6. If I pick 4, 7, it doesn't fit, just don't graph it. I mean, it's a line, we've got enough points to make a line, so that's good enough. Connect the dots to a nice straight line, and there you go. If I had done slope-intercept method of graphing, my y-intercept is equal to positive 3, because that's this number. The slope is equal to 1, which is 1 over 1. y-intercept of 3, every time I go up one, I go right one. I get the same points. So again, take your pick, they both work. This tends to be more efficient, but for just x plus number, I think the chart's just as efficient. Number 10, find the equation of the given line. Find the equation of the line. All right, y equals mx plus b. Immediately, as soon as you see those words, find the equation of the line, always stick with the y equals mx plus b idea. My intention here is to find out what m equals and find out what b equals. B first. B is where it crosses the y-axis. B is equal to 2. That's how you find B right now. It's inspection. You look at the graph, see where it crosses the y-axis, that's what B is. That's y equals 0, y equals 1, y equals 2. So that's what B is. To find M, I got to pick 2 points. It doesn't matter which 2 points I pick. I'm going to pick this point and this point. How do I get from here to here? First of all, vertically. Second of all, horizontally. And when I move, movements are always directional, so positive or negative depending on direction. So this direction is going up 1, 2, 3, 4, 5 spaces. That's a positive 5 rise. And this direction is to the right, which is positive also, 1, 2, 3, 4, 5 spaces, which is positive 5 run. Slope is rise over run reduced to a whole number if possible. If not, reduce the fraction as much as possible. 5 over 5, both positive, equals a positive 1. So the slope is positive 1, the y-intercept is positive 2. My answer is y equals x. Slope goes here, y-intercept goes there. It's positive 2, so plus 2. If it were negative 2, I'd put minus 2. So whatever sign the y-intercept is goes in between the x and the number. And that's how you do it. Number 11. Solve 3 1/2 plus 2 1/4 x equals 12 1/2. My advice on fractional equations, or in this case mixed number equations, is first of all make fractions instead of mixed numbers, and then get rid of the fraction. So 3 1/2, 3 times 2 is 6 plus 1 is 7 over 2. That's the same as 3 1/2. 2 1/4 x. 2 times 4 is 8 plus 1 is 9. And the x I would always put on top because that's where it really is anyway, even though it's kind of in the front of it, but just stick it up on top, that's a better place for it. Equals 12 1/2. 12 times 2 is 24 plus 1 is 25 over 2. So create 3 fractions that are improper fractions instead of mixed numbers, so that at this point the least common denominator of the 3 fractions is 4. I'm going to multiply by 4 to get rid of the fractions. 4 divided by 2 is 2 times 7 is 14. 4 divided by 4 is 1 times 9x is 9x. 4 divided by 2 is 2 times 25 is 50. And just like that, we got ourselves a nice friendly equation. Move the 14 over. I get 9x is equal to 36. Divide by 9, I get x equals 4. Getting rid of fractions is not a requirement, but it sure makes the problem a lot easier. I recommend doing it. Again, if you do want to get rid of fractions, though, mixed numbers are not where you want to be. Multiplying a number of times with mixed numbers is a little more complicated than it is to multiply just an improper fraction. So create improper fractions, then get rid of the fractions, then solve the equation. Solving a decimal problem. Decimal equation. Again, it's an equation, so getting rid of decimals is legal. 2 decimal places, 2 decimal places, 1 decimal place, 2 decimal places. Okay, I want everything to have the same number of decimal places. I'm going to stick an extra 0 on here, so now that has 2 decimal places also. And once everything has 2 decimal places in this case, I'm going to drop all the decimals off. If the most decimal places was 3, I'd make sure everything has 3 decimal places, then I'd drop all the decimals off. So this just becomes 44 minus 4x plus 10 equals 2x. And just like that, we have a non-decimal equation, very easy to solve. Move the 4x over to the right, becomes positive. 44 and 10 make 54. 2x and 4x make 6x. Dividing by 6 gives me x equals 9. 13, expand. First step of expand is make sure every term is simple. Simple meaning one of each letter, all powers positive. 1p, 1x, 1y, positive powers. 1y, 1p, 1x, all positive powers. 1p, 1y, 1x, all positive powers. So this is ready to go as is. I would expect on the test that problem number 13 will be ready to go as is. My recommendation for all of you has been this: multiply first, then simplify. Don't try and simplify as you're multiplying because it causes some of you to mess up. So, if I take this px over y times y over px and times positive py over x, when I'm multiplying using the multiplication rules of powers, letter times letter, add the powers. So on the top, p, x, y are all different, so I can just stick them together. On the bottom, y, p, x, all letters different. All I can do is stick them together. For the red multiplication, I am doing plus times plus, so I get a plus. P times p is p squared. X times y are different, so I can't do anything to it. And on the bottom, I got x times y. Okay. Get the product first. Top times top, bottom times bottom. Don't reduce as you're multiplying until you've mastered this. Then try reducing while you multiply, see if you still get the right answer. Okay. Most of you are trying to reduce while you multiply, get the wrong answer more often than not. So I recommend get the product, then simplify. P cancels P, X cancels X, Y cancels Y. Everything cancels, you get a 1. Okay. If you don't put the 1, it's going to be wrong, so be careful. P doesn't cancel, X cancels X, Y cancels Y, so P squared sticks around. This is a test I used to give. I made a practice test this year. I've had countless students forget that 1. So be careful. If everything cancels, there's still a 1 sitting out in front of there that's still sticking there. That's being added, and 1 plus something makes a difference. 1 times something doesn't. So that 1 is a necessary 1. Don't leave it off. Number 14. Simplify. This is just straight out exponent rules. First thing I always deal with exponents is this parentheses look. It is to the first power, so it really isn't, the parentheses are there for effect more than anything, but just to follow through the process correctly. Everything in black that's not in parentheses, I'm going to write in black. So I've got x to the negative second, I've got x to the negative 8th, I've got y to the negative second, y to the 5th, I've got a y cubed, and a y to the 0. So those things I'm leaving alone for right now because I'm dealing with this parentheses to a power. Everything else just came down. 2 is to the first power, so is, and x is to the negative 4th power. Both of these things are being raised to the first power. So 2 stays 2, x stays x, 1 times 1 is 1, negative 4 times 1 is negative 4. That's how you deal with the parentheses situation. On the test itself, that might be a 4. Then this will be 2 to the 4th power, and this will be x to the negative 16th power. Most common mistake, people want to prove 2 times 4 is 8. But again, the power multiplies by the power, the base doesn't change. So be careful that is done correctly. Step 2. Negative and 0 powers must be dealt with. Negative power here, and here, and here, and here, and a 0 power there. Okay? Everything's being multiplied, times 1 doesn't matter, so you can throw 0 powers out in a scenario like this. Everything else circled moves to the other side. So the x's on top move to the bottom, the x and y on the bottom move to the top. The 2 and the y are going to stay right where they're at. So, again, keeping everything that's the same where it's at. 2 is on top, y cubed is on top, y to the 5th is on the bottom. What's circled in green on the bottom, x to the 8th and y to the 2nd move up, become positive powers. What's negative powers on top, move to the bottom with positive powers. Okay, so that's step 2. Deal with all negative and 0 powers. I like to position numbers to the front, so I might make that happen in this step. I also like to evaluate in this next step. 2 to the 1st just means 2, so I don't have to evaluate it. If it said 2 to the 3rd, I'd probably keep it 2 to the 3rd for now, then I'd go ahead and evaluate it in this step. So in this step, evaluation, simplification. On top, I want to simplify. On bottom, I want to simplify. The top is its own problem, the bottom is its own problem in this step. So, 2 is 2, I can't make that any simpler. X to the 8th, I can't make that any simpler. Y and y, there's too many y's, 3 plus 2 is 5. Okay, to multiply letters, you add powers. Okay, on the bottom, x times x makes x to the 6th. There's too many x's, 2 plus 4 is 6. Y is just to the 5th power, there's nothing happening to it, so it stays y to the 5th. The final step is to deal with the same letter on top and our bottom. So there's too many x's, there's too many y's, there's just enough 2's. So 2 is right where it belongs, nothing wrong with it. X belongs on top, because 8 is bigger than 6. 8 minus 6 is 2. Y is exactly the same, they cancel. And just like that last problem, if everything cancels, the answer is 1. Since y canceled, other stuff didn't, just leave this as your answer. Finally, number 15. Simplify by adding like terms. Once again, simplify each term first, then carry out the algebra that you're supposed to do. So, 3x over y is what simplified looks like. There's one x, there's one y, the powers are positive. So that one's behaving itself, ready to go. This one here is not behaving itself at all. It's got all kinds of stuff going on. I'd probably do that in pieces. So maybe even on a scratch sheet of paper, like over here, here's my scratch sheet of paper. 2x cubed y on top looks really good. I got an x to the fourth and a y squared on bottom, both behaving themselves. I'm going to slide an x squared up because of that negative power. And then I've got too many x's on top, so 2x to the fifth y over x to the fourth y squared. And finally, 2 is fine. X is bigger on top, 5 minus 4 is 1. Y is bigger on the bottom, 2 minus 1 is 1. So 2x over y is what that ends up. It is plus. And this final one's not too big of a deal. It has more stuff going on, of course, than the first one, since the first one was already fixed. But 5 is fine. It's just basically the same as this step here. I've got too many y's. Y is bigger on top. 3 minus 2 is 1. Too many x's. X is bigger on the bottom. 3 minus 2 is 1. So get each term simplified as much as possible, then add like terms based on what you're looking at. So these two are like terms because they both have x, they both have y, they're both the first power, they're both in the same location. Even though this has x and y both the first power, they're upside down, so this does not match that. You can't add this to those. 3 plus 2 is 5. What made them the same was x over y. Powers do not change when you're adding and subtracting. They change when you're multiplying, but not when you're adding and subtracting. That's what this becomes. The 5y over x is an unlike term. You do not have to add those together. You don't have to get a common denominator. You simply have to add like terms. Once you've done it, circle your answer. If you have unlike pieces here that are being added or subtracted, that is the final look of your answer.